Record, there we go. So, today we are looking at lesson 7.1. We ready to go? All right, 7.1, polynomials. Polynomials. Does anybody know what the prefix poly means?
More than one.
All right, look it up. Who's got the right hand up? 4? So I like the way you're thinking. What?
Paper's big.
More than one? I think we're on the right track. Who's got the right hand up? Everyone knows. Someone, look up. Many. Poly means many. Nominals does not mean no.
No.
Alright, there's a lot of side conversations. Time to focus in a little bit. Our learning targets for today. Students will be able to find the degrees of a monomial. What is the prefix mono? 1. Students will be able to classify polygons.
Like monotone.
I don't think that should say polygons. I think that should say.
Just say polynomial.
Yeah, it should.
Polynomial?
2 learning targets for today. No big deal.
No, that might be
Order of operations.
Mm.
Hey, there still are a lot of side conversations going on, and those should stop. Order of operations. First, we're going to look at some terms, a couple examples, and a practice. I think there's only 1 or 2 practice problems, so not too bad. So here are a couple of our terms. First one is a monomial. So a monomial is a number, a variable, or a product of a number and or 1 or more variables. So by that second part, we know what a number is. We know what a variable is, just a letter. But the product of a number and 1 or more variables, that would mean like 7 times a. That would be the product of a number and a variable. Or 7 times ab. The product of a number and multiple variables. So that's all that means by that last part. And also the last part, it has whole number exponents. So a and b right now would technically be to the first power, but the monomial would also be like a 7 times a times b to the third power, or something like that. So we're looking at numbers, letters, and exponents. Some examples of some things that are not a monomial would be x to the 1.5, because we can't have our exponent to a fraction. Our exponents need to be whole numbers. Another one would be right here, -2 over z. Remember, you tell me, if we were to rewrite -2 over z, how would we rewrite that? Using an exponent. Z to the what? Close. Well, not 2, not 0. Z to the z. Z to the, I like that you're guessing, z to the -1, right? We put z on the bottom. So since we would have a negative exponent, it's not going to work for us. And then monomials cannot have an exponent that is a variable. So it just can be a whole number. If we look here at this first example, this with just a number still could be considered a monomial, because remember, it could be a number on its own, a variable on its own, or the product of a number and 1 or more variables. So then if we were to look here, even if our number is a fraction, then we're all good. Our exponent just can't be a fraction. And then like we said in the example earlier, we could have a whole number or a number that is a decimal or fraction, and it could be multiplied by 1 or more variables. So it could be multiplied by x and multiplied by y. Now, the degree of a monomial is the sum of the exponents of the variables in the monomial. So if we were looking at this first example, our definition of degree, the sum of the exponents of the variables. So we're not talking about exponents that have to do with the numbers, just exponents of the variables. The degree, if we just had -4, would be 0, because there are no variables, so we don't have any exponents. The degree of 1/2 y squared would just be 2, because we have one variable, it's to the second power, so our degree would be 2. And the degree of 2.5 times x squared times y, well, we have two variables, we have x squared and y, and if we add those exponents together, we would have 2, and really with y, there's a 1 up here that we don't write, so our degree would be 3. Let's look at a few more examples of degree. The question you might, well, not you might, that you will definitely see on a worksheet or even on a test question. Find the degree of each monomial. So if we look at 5x squared, the only variable is x squared, so our degree is 2. If we look, are these the same examples? No, just this one's very close. If we look at letter B, we have two variables, x to the first power and y to the third. So what would our degree be? Anybody?
33.
Well, remember, we need to add all the, but we don't count the number. We only look at the letters, look at the variables. So we have x to the 1 for one variable and y to the third power. So our degree would be 4.
Wait. Can you do it one more time?
Yep. So our idea of degree is that we take the exponents of the variables and add them together. That's how we find the degree of our monomial. Now, if we look at our variables in the second one, all we have is x to the first power and y to the third. So if we're adding together the exponents, we would have 1 plus 3, so our degree would be 4. Just adding together the exponents of the variables.
Oh, so you don't have that now.
Nope, we're just nothing. We're not adding. When we mess with degree, we're not talking about things that have to do with the number, the actual number. We're just looking at the variables. Okay?
Yeah.
For letter C, there are no variables, so our degree would be 0. You're going to get a lot of practice at this, so don't let it freak you out. Well, like right now. Find the degree of each monomial. Go ahead, take like 2 minutes on your own. Find the degree. I'll need to see these before you do the worksheet today. So take a couple minutes to do these. Also, do you guys like the new template? The new colors? It's very Oriole-ish.
Oh, you like that.
What are you asking, Parker? What's your question? Cheating, Parker.
I'm not cheating. I would never. Parker would never cheat.
What? Do you have a question? On 3? So we just have our only variable is y, right? And well, there you go. It's only 0 if we just are given a number, like in number 4. You can't see. Did you pull the slides in your iPad? Are they loaded? Yeah. Well, you don't have to show me yet. But yes, you'll show me at the end before you do the worksheet. All right, moving on.
What?
Those will be up at the screen towards the end, too. Don't worry. Now, we talked about a monomial, which is just one term. Now we're looking at polynomials. That's the title of this chapter, polynomials. So many terms. Like we talked about, well, a polynomial in general is a monomial or a sum of monomials. So we could have, like we have here, two different, so like 5x would be a monomial that we just talked about. 2 would be a monomial, which we just talked about. But when we put multiple monomials together, then we get a polynomial because poly means what, Skylar? What? Many. Yep. Well, yeah, T Sky Sky. T Sky. Yep. Got it. So each monomial is called a term of the polynomial. So if we're looking down here again at, I just erased some sources. If we're looking down here at this one, 5x would be one of the terms. 2 would be one of the terms. Now, the most common types of polynomials that we will see will be a binomial, so with 2 terms, and a trinomial, which will have 3 terms. We follow? Because bi is 2, tri is 3.
So are these like the formulas?
So they're not formulas. No, these are just examples.
Alright.
So we won't be dealing with formulas too much.
I figured.
But those are just examples. So over here you can see we have 1, 2, 3 terms. So that will give us a trinomial.
What was the, never mind.
The degree of a polynomial. The degree of a polynomial is the greatest degree of its terms. So if we're looking at this one in the red, we have 3 different terms here, right? 3 individual terms. If I ask you for the degree of that trinomial, then it would just be the greatest degree of the term. So the greatest degree, we would have 2, 1, and 0. So the degree would be 2.
2, 1, and 0.
Our degree of this, of x squared, would be 2. So we're talking about the exponents that are attached to the variables, right? So if we have x squared, just like we did earlier, the degree would be 2. Correct?
Because it's squared?
Because it's to the second power.
Okay.
Yep, that's the exponent we have. With 5x, if we look at 5x individually, x has an not imaginary, it has a 1. X is to the first power. So it would have a degree of 1. If we look at just the 2, there are no variables attached to it, so it has a degree of 0. So those are the individual terms. If we want the degree of the entire trinomial in red, we want the degree of the entire thing, we just would write down the degree, or the greatest degree, which would be 2. Here, are you following? Again, we'll get lots of practice to clear things up. But you'll want these things written down to refer to during practice. We are not, on the other hand, if I ask you for the degree of this trinomial in red, we are not adding all of these degrees together to get a degree of 3. Yep, that's easy to confuse. We are not adding them all together. We're just taking the term with the greatest degree, and that would be considered our degree of the entire trinomial. Questions on that before I move on? Now, we have a certain form that we like to write polynomials, and it's just standard form. So you can see, really, in this question, well, we'll start with letter A. In letter A, they give us the polynomial of -3z to the 4th. If we write it in standard form, it's the same thing. That's the only term. And it has a degree of 4 because z is to the 4th power. And it's a monomial because there's only one term. These would be some good examples to have written down. A, B, C. You don't have to write the directions down, but this chart could be a little bit helpful. Or screenshot it or something to refer to. If we look at letter B, 4 plus 5x squared minus x. Now listen closely, because this part is pretty important. When we write something in standard form, we want to write it from the highest degree down to the lowest degree. So the term that has the most amount of exponents down to the term with the least or 0 exponents. So you can see it's pretty obvious in part B that 5x squared has the highest exponent value out of any of these terms. So we want to write, if we're writing in standard form, we need to write 5x squared first, followed by a negative x, because that would have the second highest degree, and then lastly 4, because that would have, doesn't have any variables, so we don't have any degree, that's 0 degree. Again, overall, the degree of this trinomial would be 2. We are not adding together all the individual exponents. We are taking the greatest degree, or the term with the greatest degree. So that would be x squared. It's a trinomial because there are 3 terms. Lastly, in letter C, 8 times q plus q to the 5th. If we were to rewrite it in standard form, we want our term with the highest amount of exponents first. So that would be q to the 5th plus 8q. Our degree, q to the 5th, has our highest exponent value, so our degree is 5, and there are 2 terms, so it is a binomial. Are you following with me on what standard form, what we're looking for?
No, I'll write something down.
You're writing stuff down?
No, I'm trying to go down.
Alright. Well, lots of practice. Today, I think that's our last slide, yeah. Today our practice is writing things in standard form, giving the degree, and giving the type of polynomial. So we're going to get lots of reps on this. Before I move on to the last practice, do we have questions? Okay. So here's your last practice. You have to do exactly what I just showed on that slide. Write the polynomial in standard form. So in order from highest to smallest with the exponents. Identify the degree, and then lastly, classify the polynomial by the number of terms. So when it says classify, is it a monomial, binomial, trinomial? What are we looking at?
A mono, a tri, and a something.
I think I wanted to use both my screens. I'll get the first. Did that beep?
Yeah.
Did it really?
I think. Oh, I did. It's
I might have just turned it off.
beep.
Yeah, it's on. I'll get the first problem up there again.